Hello everyone, welcome to my YouTube channel. In this video, I'm going to discuss about current electricity. As in modern world, we all are using electric current more or electric energy more, which can convert into any other form of energy. So what is that current mean? What is that electricity? And that electricity, how it will flow from one part to another? What are the sources for this? Which factors are responsible for the flow of current in a circuit? What is a circuit means? All this we'll discuss in our video. So let's start our video current electricity. It's the part 1 and I'll come near you with part 2 with some more aspects of this current. So first thing to know, what is electric current? This and how that current will flow from one part to another. So let's start our video or our discussion about current. First thing to know, what is current? Electric current term when will come the rate of flow of charge in a circuit. So what is charge? Charge two type. One is positive charge, one is negative charge. So whenever negative charge flows from one part to another, or when we'll take two electrode, positive electron, negative electrode, from positive side, the positive charge will move towards negative, and from negative side, the negative charge will come towards positive. The negative charge, which is electron, and we are taking the direction of flow of current as the reverse of direction of electron flow, or simply we can say the opposite of direction of electron flow is the direction of flow of current. What is current? How much rate of flow of current or rate of flow of charge in a circuit. That means how much amount of charge will flow in a circuit, in a path, in a closed path from switch or source to the receiver in unit time will get current. So this current again will come to the types of current depending upon the source, depending upon some properties. Current divided into two parts, two types of current. One is direct current and second is alternating current. DC direct current, AC alternating current. So in this, we'll get now about the different aspects of this direct current and alternating current. If we'll come to direct current, what the direct current actually mean? Direct current means whenever source will provide that current, its direction will remain constant, its magnitude, the amount will remain constant, and always the current which is flowing from one part to another, there is no voltage high or voltage low, or simply we can say the current of constant magnitude. The amount of current every time remain constant. Second thing, it flows in one direction. There is no change in direction for the flow of current. And when it comes to the direct current source is a cell or battery. What we are using in mobile phone, we are using in torchlight, we are using in remote. All these comes in this part or cell part. A combination of cell we can say as a battery. So direct current, the source of direct current is cell. Welcome to alternating current. Alternating current just the reverse of direct current. Or simply we can say alternating current time direction of current will change. Alternating current time will get high voltage, low voltage. Alternating current we are getting from our mains supply. The current where magnitude varies, where direction varies, always will get uh, upward movement and downward movement in a graph for alternating current. Alternating current direction change. One time it will go upward, one time it is coming downward. It is called SC half cycle and it will complete one cycle. and how much time it will change. With that we can calculate AC supply frequency also. And this one mainly coming from generator, AC generator. It is coming from main supply. So this is the two type of current. One is alternating current and one is direct current. Next one, here you can see the cell. Here we have discussed about the source of direct current, cell. What does cell actually mean? Cell means, whenever we come to the word cell, cell is that device which convert chemical energy to electrical energy. Same one we can get in case of remote, in case of clock, in case of our mobile phone, inverter battery, all this in the category of cell. Cell which convert chemical energy to electric energy. When it sends current in a circuit, means whenever cell is in use, it convert chemical energy stored inside it to the electric energy. So here, its cell consists of two electrodes. One is cathode and one is anode. And inside that, it is having electrolytic solution. An electrolytic solution, acid we can take, base we can take, because strong acid and strong base are the good electrolyte. What does an electrolyte mean? Electrolyte means whenever any substance conduct electricity in their aqueous solution or molten state, that is called electrolyte. That acid also may be electrolyte, base also may be electrolyte, and some salt solution can be used as electrolyte. Electrolyte means which conduct electricity in the aqueous solution or in molten state. So here people come to the type of cell. Cell mainly divided into two parts or two kinds of cell or two type of cell. One is called primary cell and one is called secondary cell. So what we can say is the primary and secondary cell. Here will come with the detail about this primary and secondary cell. So type of cell means depending upon their use, depending upon their rate, depending upon the amount of energy they produce, we'll get two type of cell. One is primary cell and one is the secondary cell. So first one, it will come to the primary cell here. Primary cell are of different type. Here you can see the simple cell, dry cell, Daniel cell. All these are the type of primary cell. Primary cell convert chemical energy stored inside it to electrical energy. And once the energy conversion over, means total amount of chemical energy changes to electric energy, we cannot again charge to this battery or this cell. So primary cell, in primary cell, the reaction is irreversible, means one time only chemical to electrical and over. Here, this cell discarded after use because it cannot be recharged. And here we can see it is light and cheap, means it is weight of this battery or this cell is not more, it is of less weight. Cheap means its cost is very less, 10 to 20 rupees. It is capable to give only weak amount, weak current. You will see in a remote control we are using two battery, two cell. Means it is the amount of current given by its primary cell is very less. So for a larger aspect or when we want more current, that time we cannot take the help of primary cell. Primary cell only applicable to that part where we need less amount of current. And when we'll come to the next part, which is our next type of current, which is or next type of cell, which is secondary cell. So in secondary cell, all these what you can say, the limitation of primary cell overcome in secondary cell. So what is secondary cell? Secondary cell, lead acid type cell, alkaline cell, lithium ion cell. So all these cells are the secondary cell. Secondary cell is used in the camera battery. It is used in mobile phone, inverter. We are using drop. In that it is secondary cell. Secondary cell, electric energy convert to chemical energy first. That chemical energy store when we are using a term that will charge to the battery, means will give the electric energy first to chemical energy. Then when the battery in use, chemical energy will convert into electric energy again. Means it is a reversible reaction. Means always in case of a secondary cell will get uh, reversible reaction. It can be recharged, means we can charge this battery and it provide a low as well as high current. Depending upon the use, depending upon the capacity of that battery, it can give, some battery are giving less amount of current, some are giving more. It is heavy because if you do the inverter battery, it is having some weight more, and costly, means the rate is very high in compared to primary. So primary and secondary cell, these two cell both are used to change chemical to electric energy, but they are having a certain difference between them, because one can be recharged, one cannot recharge, and one is heavy and other is light, one is costly, one other is cheap. So there is uh, certain difference between this primary cell and secondary cell. So here we can see electric current. What we've discussed in the first of this video, that what is the electric current mean? Whenever there is a flow of charge, we'll get the current. Means charge is flowing now from one part to another. Here one term is conventional current. Means as electron is moving from negative side to positive side. So conventionally we are taking the direction of flow of current as the flow of positive charge, or simply we can say the opposite direction of flow of electron is the direction for the electric current. Means current is flowing, conventionally current direction is from positive side to the negative side, and current is the rate of flow of charge. Rate of flow of charge means how much amount of charge will flow in a unit time, or simply you can say, here you can see the mathematical expression for this: current equal to charge by time, where I is the current and I is the current and Q is the charge, T time. For how much time current flows from one part to another, we'll get here the current part. And one more thing here we'll get, in case of all this part, when we'll take uh, current one, I equal to Q by T, and Q equal to I equal to Q by T, that means Q equal to IT. And current one, again you can see that current is having a different unit. Current is having different aspect. Current can flow from one part to another. So when we'll take current, current is flowing from one part to another in case of a conductor. Because in conductor there are free electrons. Free electrons mean the electron in the outermost cell, which is free to move, where the force of attraction from center is very very less. And in case of electrolyte, both positive and negative ions, which is cation and anion, these two are also responsible for the flow of current in case of electrolytic solution. So when we take this current, current is the flow of charge, but quantum nature of charge, it will take, here I am using a term quantum nature. Quantum nature of charge means charge always flow, or amount of charge is the integral multiple of the charge. Means any time also will not get charge number as fraction or decimal. Total charge equal to n into E. E is the charge of one electron, which is 1.6 into 10 to the power minus 19 coulomb. N, number of electron or charge. So if we know the number of electron, we can calculate how much charge, or if we know total amount of charge, then we can calculate the number of electron. And here, one more thing, the direction of convention current, what I told before also, it is opposite to the direction of motion of electron. And next one, it will come to the unit part. Unit of our electric current, I equal to Q by T. That means Q is the coulomb is the SI unit of charge. T, time. So coulomb per second or ampere is the unit for electric current. So how we can define 1 ampere? 1 ampere can be defined as when 1 coulomb of charge is flowing through a conductor for a time period of 1 second, we can say current as 1 ampere. And this current we can measure by using an instrument called ammeter. It will show the amount of current flowing through a wire or flowing through a conductor. So, and this ammeter also used in a circuit in series, means in a straight line we will use. In the same line of the wire we can use the ammeter, which is having two connector, one part for the positive terminal, one for the negative terminal. And when we'll connect the wire and we'll switch on or the current will flow, we'll able to know about the amount of current. Next one, circuit. I'm using a term circuit from the first slide. Means from the first of the video I'm using the term circuit. What the circuit means? Whenever we get closed or means we'll switch on, and from that switch current is going to the bulb. Or when we have connected a bulb with a battery, from the battery current is going to the bulb. It is a closed circuit. It's closed path. It means from the source which will provide the current to the receiver which will receive that current. It will take closed uh, system, that is the circuit. This circuit can be of two types. One is open circuit, one is closed circuit. Open circuit and closed circuit means one is open circuit, one is closed circuit. So open circuit means when there is no flow of current, means somewhere between the source and receiver the connection is failed. That is an open circuit. Closed circuit means when the source is fully connected with the receiver and current will able to flow now from the source to the receiver. So we got two type of circuit. One is open circuit and one is closed circuit. Here you can see the term potential difference. What that potential difference means? So here we will discuss what is that potential difference. Whenever you will see any battery, in that battery it is written 1.2 V, 2.5 V, 0.5 V, 220 V, means that is the potential difference between the two terminals, between positive and negative terminals. So here we are going to discuss about this potential difference. First one you can see here. The work done to bring a unit positive charge from infinity to a point is called potential. Means whenever charge is coming from one point to another, from the infinity, from a very larger distance to a point, means from the source to the receiver, that time how much the work done by charge, because work done means what? The product of force and displacement. So here whenever charge will move from one part to another, when it will displace, it will do certain amount of work. That work done of charge to move from one point to another is the potential. So difference of work done between any two points will get here potential difference. Means when we take 2 points A and B, means when the charge is moving from A to B or B to A, means 2 points up to 1 point, if the charge is having work done 10 joule, to the second one is having, let be 20 joule. So what is the potential difference between these two, or how much the work done difference between these two? Then we can say 20 joule minus 10 joule. Means work done by charge between any two given point in a conductor, or whenever charge is moving from one part to another in a conductor, or one conductor to another, how much the work done by the charge will get the potential. Means potential difference V is equal to work done by charge, or V equal to W by Q. So unit when it will come, work done having the unit joule, and coulomb is the unit for charge. So joule per coulomb or volt is the SI unit for our potential difference. Next one we can see here how we can define 1 volt, because we'll choose that type of unit which should be well defined, or unit should be well defined. How can define this potential difference 1 volt? Means when 1 joule of work is done to move a unit positive charge of 1 coulomb from one part to another, the work done between them, or the potential difference between them, is said to be 1 volt, or potential difference between 2 points is said to be 1 volt if work done in transferring it to take 1 coulomb of charge from one point to another is 1 joule. And this potential difference or voltage between any 2 points can be measured by using a device called voltmeter. Voltmeter always connected in a circuit in parallel. Parallel and series, two type of connection for any electrical appliance or for any uh, registers. Next one will get another factor on which the flow of current depends. So that factor is the resistance. What the resistance means? Potential difference, the work done by the charge, means the work done between two terminal 1.2 volt, 2.5 volt or 220 volt. Resistance. Resistance actually is the obstruction offered to the flow of current by a conductor, means when the charge is moving from one part to another. Any disturbance produced in the middle is the resistance. So resistance can be given by whenever charge is moving from one part to another, the free electrons are responsible. Free electrons will help them to move, but when they will collide with other or nucleus of any atom, the speed will decrease. So that's the obstruction, that's the resistance. Resistance of metal is very less. Semiconductor or metalloid time little bit more, but in case of non-metal, it is insulator, means which will not allow the charge to move. So always this electron flows in a wire and of metal. But what is the cause of this resistance? Resistance, when the electron will move from one part to another, they can collide with other uh, subatomic particles of the matter, which because of which the speed will decrease and sometimes the charge will not able to move from one part to another. That's what we can say as the resistance. And having we can say resistance is the obstruction of what? So one term we got current, one we got potential difference, and third one the resistance. The relationship between current, potential difference, and resistance was first time given by the scientist George Simon Ohm. George Simon Ohm got a relationship between potential difference and current. According to George Simon Ohm, or according to the Ohm's law, when current is flowing through a conductor, it is directly proportional to potential difference across its end, provided temperature is constant. That means whenever current is flowing in a circuit, it depends upon the voltage, it depends upon potential difference. More the potential difference, more the voltage, more current will produce. Less the potential difference, less the voltage, and less amount of current will produce. That means V is proportional to I, where V is the potential difference, I is the current, and V by I is constant. So that constant Ohm has given the term or used the term resistance for this. For that reason, the unit of resistance is volt per ampere or ohm. And here, how we can define the resistance of 1 ohm? Here you can see V by I equal to R. So when 1 ampere of current will flow through a circuit with potential difference 1 volt, the resistance is said to be 1 ohm. Means unit will take that type, which can be, unit should be well defined. Is that type of unit you will choose, which one will be able to define properly. So here you can see the unit ohm, where 1 ohm we can define that 1 ohm is the when 1 ampere of current flows through a conductor with potential difference or voltage in that particular source, or potential or work done of the charge between that two terminals is 1 volt. So limitations of Ohm's law. Ohm's law only applicable for metals or conductors. Ohm's law applicable when temperature remain constant, because with the change in temperature, again this resistance change by its own. So external factors should remain constant. External factor like temperature remain constant, and is only applicable for metals or conductors. Here you can see factor affecting resistance, means on which factor resistance of a conductor depends, or by changing which factor we can change this resistance. Can we increase or decrease the resistance? So that one we'll discuss in this part. So here first one equal loop material. As we have discussed before, resistance of conductor is very less. Semiconductor little bit more, and non-metal or insulator case the resistance is very high. Conductor means which will allow the current to pass, which are metal. Insulator means which will not allow the current to pass, which are non-metal. So conductor have less resistance, insulator having more resistance. So that means resistance depends upon the material. Second one, dependence on the thickness of conductor means more thicker one it will take, the number of collision will decrease, because of which resistance in a body will decrease. That means when we are taking a wire with thickness more, that time resistance is less. Third one, depending upon temperature, because once the temperature increase, the particle now will get kinetic energy, because of which their motion will increase, and once they will start moving in a very high speed, then collision will increase, because of which resistance increase. For that reason, Ohm's law time we got temperature should remain constant. With the increase in temperature, resistance increase. With the decrease in temperature, resistance decrease. But in a certain point, a certain temperature, if resistance becomes zero, that is called superconductor. Superconductor means when a conductor having resistance zero at a given temperature, that is called superconductor. This one first time given by Camelin Honest by taking Hg or mercury. So superconductor time or superconductor case, resistance is zero at a particular temperature, when temperature will come to very low. Last one you can see here, it depends upon the length. When charge will move a larger distance, number of collision will increase, because of which resistance will increase. That means resistance directly proportional to temperature, resistance directly proportional to length, but resistance inversely proportional to area of cross section. So in this video we got different aspects of current, different uh, term used in current, different factor on which current will flow in a circuit, and what is a circuit. In my next video, I'll come with some instrument used in a domestic circuit or used in a circuit, how to show a circuit with symbol or circuit diagram, and some numerical based on all these relation. So to get more updates of physics, like my channel and click on the bell icon to get some more updates.